Here comes the applications of finding degrees of freedom of system. The examples of degrees of freedom of some of the systems are shown considering the figure A. The number of joints in the system is 3. The number of links of the system are 3. And the number of higher pairs are 0. So according to the Kurzbach equation, M is equal to 3 into of n minus 1 minus 2j1. Applying these parameters in the equation, we get the mobility as 0. Considering the second mechanism of B, it's a slider crank mechanism. It's a slider mechanism having number of joints as 4 and the number of links are 4. So applying these parameters in the mobility equation, we get mobility as 1. Consider the figures mechanism C. It's a 4-bar mechanism. The number of links are 4, number of joints are 4. Applying these parameters in the mobility equation, we get the mobility as 1. Considering the mechanism D, the number of joints are 5 and the number of links considered are 5, and the mobility obtained will be 2 by applying the Kurzbach criterion. And some of the applications of Kurzbach criterion on structures are shown above. Considering the mechanism of A, the number of links are 5 and the number of joints obtained are 6. The mobility of the mechanism obtained will be 0. So it is a structure. Consider the case of the mechanism B. The number of links are 6 and joints are 8. The higher pairs, number of joints in the higher pairs are 0. The mobility obtained will be minus 1, which indicates that it's a superstructure. There are cases where this criterion fails. Two of the figures A and B indicates that the mobility of the mechanism fails. The mobility criterion fails in these cases. Where in the first case A, the link 5 is an intermediate link and the mobility obtained will be equal to 0 in this case. It is n equal to 5 and j1 equal to 6. But considering the second case, the length of the link 5 is equal to link 2 and link 4. So we know that it will be having a single degrees of freedom, but the mobility obtained will be still equal to 0. So the possibility of it to be having 1 degrees of freedom is not to be neglected. So that indicates the resulting criteria is a failure. Sometimes a system may have one or more links which do not introduce any extra constraint. Such links are known as redundant links. It should not be counted to the degrees of freedom. In such case, we neglect the number of degrees of freedom of redundant degrees of freedom from the mobility criterion. It is shown as equation 2. M is equal to 3 into of n minus 1 minus 2j1 minus j2 minus mr. Mr is the number of redundant degrees of freedom.